Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen. Wherever your Zoom controls are, you should see a little button that says Q&A. Click on that, hit submit, and I'll get to those at the end. If you're watching on YouTube, just use the live chat function wherever it is on whatever machine you're on, and I'll get to those questions and comments at the end as well. So my name is Jason Gabrinas. I'm one of SnapOn's national diagnostic technical trainers. Been in the training department for 9 years now, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before that, it was a couple years as a diagnostic sales rep with SnapOn. So I had about 30 different SnapOn franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So worked at a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. That's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher cars that would come into my path. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is, we're continuing from last week, which was component testing part 1, talking about why we need to test components and the easiest way to test components, which would be the guided component test module, and just going through kind of analyzing one signal. So now we can take it to another level and add additional channels. And by doing this, it allows us to see how different things react to each other and how they work with each other over a period of time. So we have our time base is going to be the same across all of our different channels, and we're going to see how they line up and how they interact with each other. So in order to do that, we're going to talk through an example here. So we have a case study, and it's on a Subaru with a flashing check engine light. So under hard acceleration, and only under hard acceleration, the engine light flashes. So in this case, it's maybe merging on a highway, going up a steep incline, something of that nature where you really got to hammer down and get some good thrust behind there. Under hard acceleration, 100% throttle, 100% load, that sort of thing, engine light flash. Cruising normally, though, no engine light. So if they were merging onto the highway, it would flash, and then cruising in the left lane, what have you, no engine light present at all. Other than the flashing check engine light, this car had no other drivability concerns to speak of either. So even as it was flashing, they didn't really notice anything wrong with the car. But obviously, that's a concern, because what's a flashing check engine light? Well, it's a catalyst damaging event. Usually it's a misfire in that case. So they were concerned, obviously, so wanted to bring it in. And first thing we want to do on any vehicle, drivability complaint, engine light, whatever, we want to do a code scan. We want to scan through all the vehicle systems. So we'll go on a code scan there. And we can see in history, and history only, we have a P0303, which is a cylinder 3 misfire. So let's go and see what we can find out. Now, in this case, this is on a Zeus, so we have Fast Track Intelligent Diagnostics on this tool. So we can go and click Diagnose, and it'll bring us to our Intelligent Diagnostics landing page. So we can see we have TSBs here, top repairs graph, smart data. In this case, I want to look at those TSBs, because that's the first place you're going to want to look anytime diagnosing things. If there's a TSB, that's a good place to start, because that may be solving your problem right there just by reading the TSB. So we'll go in there. So we got 4 of them. The first one says difficulty starting, rough idle, cam position, pardon me, or misfire DTCs, bunch of P03 codes in there. Let's see what that one's all about. So if you walk into this TSB, it's going to tell you it works on 11 to 14 Foresters, 12 to 13 Imprezas, etc., on certain engines. So this bulletin provides inspection and repair procedures for intake and exhaust camshaft position related and or engine misfire DTCs for the FA and FB engine equipped models listed above. The camshaft position sensor clearance may be out of specification, causing these conditions. One or more of the DTCs listed above is set. In addition to a check engine light coming on, there may or may not be customer concerns of rough idle, extended cranking, or a no start, so depending on the severity. So the camshaft position sensor clearance may be out of specification, causing these conditions. Now, this strikes me as a little odd, and you may be wondering, why in the world would that cause a drivability problem? Well, let's take a closer look at the cam sensor on this vehicle. So we got two cam sensors actually, because it's horizontally opposed. There's one on either side, and they're at the top of the timing chain cover right there, kind of towards the front of the engine. And you can see there's a pretty standard camshaft sensor there. One bolt goes into the hole, and then there is a disc on the end of the cam pulley that it will read. And we see we have a gap right here. So here's the electromagnet part of the sensor. Here's where the wires go in, and then we got a little coil of wire in here, an electromagnet, and we have this disc. So it reads the disc as it goes by. So what this does is a 3-wire Hall effect sensor. What it's going to do, it's got power, ground, and signal. So when it is on, it is going to generate a magnetic field. Now, I know this isn't 100% the best drawing of a magnetic field, but it's close enough. We have waves, magnetic waves. And it's more of like a 360 thing, but hey, it's 2D, but whatever. So we have a magnetic field here. It's going to generate a magnetic field. And as this goes by, as it turns, when it affects the magnetic field in a certain way by dropping out in this case, we see we'll get a pulse when that happens. So no metal there will give us a pulse. When we have metal going by, the pulse goes away. So either it has metal in front of it or it doesn't. It's disrupting the magnetic field. And let's just say, for the sake of argument, that this is a normal spacing. That's how far apart it's supposed to be. Everything looks good. So what if we move it in a little bit closer? If we go in a little bit closer, you can now see that magnetic field is touching this ring a little bit more. And it's affecting this magnetic field in a different way. Different than what the manufacturer intended anyways. So we can get an erratic signal. Maybe we get a larger block in here. Maybe we get additional blocks in there, depending on how that affects the magnetic field. So there's the problem. So if we pull up the bulletin, first thing it does is it gives us a Labscope pattern. It's on a Subaru Labscope, with anything with 3 or more channels to be able to set up the same way. Channel 1 is going to be the crank sensor. Channel 2 is going to be the right side cam sensor. And channel 3 is the left side cam sensor. So horizontally opposed, as we said. Now, if you look at the crank sensor, that is also a magnetic field generator, but that works in the analog way instead of the digital way. We're creating a pulse. Instead, we are generating a signal based on the teeth. Now, you see we have what would be a double gap, a single gap, a double gap, a single gap. So every time it goes around, it's going to go past a double gap and a single gap, and back to a double gap. So one's on, say, top dead center, and the other one's on the other side, the opposite side. And then it counts the teeth. Now, if you see here on the right side cam sensor, we got blip, 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 then a gap, blip, blip, and then there'd be another blip over there. Same thing here. We got a blip and a gap, blip, 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 gap, blip, blip, blip. It's just going to be 3 blips in combination. Now, you see in this case, I have a double gap. I got a single gap, and then I got a blip. And I got a single gap, a blip, and a gap, double gap, blip, blip, single gap, blip, blip. So based on the combination of those 3 things, we can have 4 separate patterns that can arrive. So this is what tells the computer what cylinder to fire when. And if you drew a straight line through all of those, I think you'd agree that they all line up. So this is nice of Subaru actually giving you here's what a known good pattern looks like. Known good patterns, especially on cam crank correlation, can be hard to come by sometimes. So it's nice that they do that. We go a little bit further though, it gives us this pattern. And same setup. Crank sensor, right side, left side. So what we are seeing here, this large square, is actually supposed to be a gap right there. So 1, 2, 3, and then a gap, 1, 2, 3, and then a gap. And you see we got these extra things going on, extra squares. We got squares where there aren't supposed to be squares, especially right here in this gap. So what it sees is single gap, blip, blip, double gap, blip, blip, single gap, blip, nothing, double gap, blip, blip, single gap, blip, blip, double gap, blip, blip. So it fires whatever this cylinder is twice. And it doesn't fire the cylinder that's supposed to be over here because it sees the pattern incorrectly because of that gap being too close. So how do we fix it? Well, you're going to have to read through that TSB a little bit further, and it tells you what to do. It tells you want to check the pattern. If the pattern is bad, you can go in, and then there's 8 different part numbers of shim in 1/10 of a millimeter increments. So 1/10 up to 8/10 of a millimeter. You put this correct shim in there, you torque it down, double check it with a lab scope. If everything looks good, you ship it. So how are we going to test that with this Zeus? Well, the Zeus has 4 channels, so we should be able to set it up pretty much the same way. So the easiest way to do it is going to be in a go and guided component test. As we go in a guided component test, we see we get a crank sensor, cam sensor, and the like. So let's check that cam sensor, because that's where the problem lies in the one cam sensor. It's too tight. So first thing is always component information. We already kind of learned about how it works. So I just talked through that. So we're going to go right into the signature test and see what we can see. So we hooked it up and hooked the yellow to the cam signal, which is going to be pin number 2. So right there in the middle, black to a known good ground. Also note that it is harness side back probing the cam sensor. So always gives us that information. Where am I hooking up? Where am I plugging? So in this case, looks like it's good. We got a 5-volt square wave, and then that's where the big gap is. So we don't have any weird stuff going on. So that looks like. Next thing, we'll go to the crank sensor. Pull that up. Make sure we got our double gap, single gap going on. This is a analog sensor. So we have 2 wires instead of 3. We got power and ground, and then it just cycles back and forth. Notice how we have a positive and a negative. So it should be -7 to 7 volts or more, depending on the voltage of the system, what's going on with the running. So it looks like in this case, we got, 12, 13 volts, whatever it happens to be on either side, because it's idling. Pardon. So you see we got a double gap, single gap, double gap. Everything looks good on the crank. But what if I want to compare the crank and the cam at the same time on the same screen? Well, we can do that too. So we go up to meter. It's going to make it full screen, just makes it a little easier to see. Then we can come down here on the bottom, click it a couple times, and that'll bring up my setting. First batch of settings is where I can turn on additional channels. So it's under profile. So we got the, and we've talked about that last week too. But we got the eyeballs. So turn on the eyeball, it'll turn on additional channels. So we add in the 2 cam sensors. So we can see here we got a gap and a blip. And then we got 2 blips lining up with that double gap. So everything looks pretty good. Now, what if I didn't have a 4-channel scope? What if I only had a 2-channel scope, like on a Triton or on a Motive? Well, we can do that too. We could just we'd only have to do it with each individual side. So we'd have to do one side at a time. Now, also with the 4-channel scope, that gives us an additional channel, because we only need 3 channels to do the 2 cam sensors and the crank sensor. So in this case, I added an additional channel, which is where the injector fires on cylinder 1. So if the firing order is 1, 3, 4, 2, and then fires again right there, and use that as a trigger point in order to kind of keep that in place. Every time this cylinder would fire, it's going to be right there. Phew, pardon me. Goodness gracious today. So every time that fires right there, it's going to keep it right there on the screen. So that way I can have my firing order right there. Going to lock it in place. Nothing's moving around. Nothing's doing anything weird. I could even take it another step further and separate it out so it kind of looks like that Subaru pattern. So we got the crank on top and the 2 cams, and we can see how everything lines up. We can draw a line in the middle if we wanted to. And we could even take it another step further if we wanted to see my known good pattern on the left and my pattern coming out of the vehicle on the right, and see, do they match? How do they look? Do they look correct? So let's walk through how we would do that live on the tool. Oh, that's not it. All right. So here is my landing page. I'm on a 2011 Subaru Forester, just like we were in the case study there. TSBs, we got 5. So let's go in there. So there's that same one right there that we looked at earlier. This has actually been updated since. So it was updated in 2014 or 2013 bulletin. We can come down here. There's our different part numbers of shim we have, in tenths of a millimeter. So they want to use a depth gauge to measure it. And if we need a flat spot without a depth attachment, we can just use a washer. But here is we're talking about our gaps here. So we have our double gap, single gap, double gap, single gap. And there's a time window that this pulse needs to happen within. So that's normal. So 1, 3, 2, 4, depending on what the combination is. When we have this problem, we have these erratic signals that are entering that window. So it should be 3241, 32. It's 4241, 4241. So it's not even firing cylinder 3. And that's why it gives you that erratic, maybe a misfire, so to say. In this case, we're not outside of the range. It could still look like this, but it's not outside of the range of the window. So it's not causing a problem. So you could almost have a problem, but not quite. Gives you the shim. Gives you the gap. Here's how big the gap is supposed to be between the top of the plate. Don't measure in the notch, measure in the top of the plate. Put your depth gauge in. Do a couple measurements. It's going to tell you what to do. Then we're going to make sure we get the proper shim to shim it out to the adjustment for the clearance. Do a little bit of math. And then there we go. So I want to keep this known good pattern up here so I can see that. So there it is there. Now, next thing we did was we wanted to load into the guided component test. We're talking about component testing. So let's go into the home screen and we'll go into guided component tests. Now, in this case, there's over 5 million guided component tests within the tool. It goes all the way back to 1981. But in this case, I want to look at the engine on this car. And let's look at the crank sensor first. We'll start there. We want a little bit of component information. We can take a look in there and see what we have for information. So it's a magnetic pulse generator that outputs an AC voltage. As engine RPM increases, frequency and amplitude increase. Sensor provides RPM and crankshaft position information to the ECM. Great. Here's what it looks like. Okay. It's also located at the top rear of the engine driver's side just before the bell housing. So it's actually kind of on the back of the engine, unlike the old ones that used to be on the front of the engine. So you can do a signature test here. Yellow to crank positive, black to crank negative, should swing -7 to 7 volts or more, depending on voltage of the vehicle. And there we go. There's my crank sensor simulated. You can see I got double gaps and single gaps floating right by. Looks pretty good. So next thing we want to do is we want to add some channels. Come down here, add some channels, channel 2, channel 3, channel 4. All right, there's all my stuff on the screen. Now it looks like it might be kind of matching up. Looks like it might be okay, but it's kind of hard to tell because everything's kind of moving around. Let's pull this one down the bottom here because I don't want to. That's my fuel injector. Now we have one of the cam sensors. That looks pretty okay. I can't really see this other cam sensor over here, though. So you can see we just get these tiny little blips. Now, is there something wrong with that cam sensor? No. If we look at the way it's set up, we can see the scale is automatically at 400 volts, which is way too high for what we need. We're going to set that down to 10 volts because that's only a 5-volt signal. So now we got this nice big 5-volt square wave right there is what it's supposed to look like. Now the blue is smaller. Is there something wrong between the two? No, it's just, once again, it's our setup again. So we'll just go down to 20 volts and change that to 10 volts. Pull that down a little bit. Now we can see my cam sensors and my crank sensor. And then we can do 10 volts on this one too if we want for my fuel injector. Now everything's kind of going real crazy, kind of hard to see. It's just floating across the screen. I need to lock this in place. Now, the whole reason I added that 4th channel there, or the fuel injector, because that's only going to fire one time in the firing order. So if I want to lock this in place and leave number 1 right there, I'm going to hook up to that number 1 injector on channel 4. I'm going to come over here where it says slope. Click on that, and it's going to lock itself in place on this red channel right here. So that is my, say, 1342. 1342, and I can see 2 times through of the firing order on this screen, and we'll see everything kind of moves back and forth by itself. Everything's kind of locked in place where it needs to be. Now there is a lot going on. We got yellows and greens and blues and reds, and there's a lot of things, a lot of stuff going on the screen. So now I want to separate these out a little. So next thing I want to do is go to setup, and I'm going to go to view. And I'm going to go to my layout, and we can do 1 window, 2 windows, 3 windows, or 4 windows. Now I got 4 channels, so I want to do 4 windows. That'll stack them on top of each other. So that looks real nice. Now, if I want to pull this down, make it a little easier to see there. If I want to turn on my cursors to see what's going on, I can see how that's all lined up right there. It's all lined up right there. Everything looks pretty good. It's within the window. Same thing over here. Same thing over there. Everything lines up within that window. So in my mind, according to that known good pattern, this is a good pattern. Everything looks good on this particular vehicle. Now, if it was a little out of sync, we'd be able to see that too. If it was a little off to one side or the other, be able to see whether it's advanced or retarded timing, be able to check timing chain with this. Now, I want to be able to see these on the same screen, though, with that known good pattern as well. So the next thing I'll do is go up to meter. I'm going to put it in a window. I'm going to leave that there. I'm going to go back home in the scanner. There is my TSB that I was looking at earlier. I can come down the bottom, pull up the Windows taskbar. I can see scope viewer. I can move that one over to the right. You see how the window kind of turns like an outline there. If we let go, it's going to snap to the right. This one I'll snap to the left, and now we can see them right next to each other. So I can see here's what's going on the car. Here's what's going on a known good pattern, and they look pretty much the same. Be able to see that side by side. It's pretty helpful to be able to do that. If you wanted to do, say, a functional test over here, you could do that. Watch the scope results at the same time. Do functional test, data stream, see how that's going over there as well. So pretty useful to be able to see that side by side and being able to set up the scope in that way where we can have all the channels separated so we can actually see what's going on. A couple little more advanced tips when it comes to using the guided component tests in the tool, using the scope in the tool, so to say. So this one's a little bit quicker of a class because we're just kind of expanding on the last class. So that is my time for this afternoon. Let's talk about a cool contest. If you are a SnapOn scan tool owner and you're in North America, that would be the US and Canada, and you have a SnapOn scan tool, which would make you a SnapOn scan tool owner, as long as that tool is able to be updated to 22.4, which would be the current software release that just came out in October, as long as you're able to get that thing updated by the end of the year, you will be entered to win this massive workstation over here. This is a 36-inch Epic with the hutch locker, or the top hutch there, whatever you want to call it. Riser. There we go, riser. I always get that wrong. So it's an Epic with a riser, and inside that riser is going to be a Zeus Plus with a dock, with a the docking stand, the docking dongle, and then it's going to have a 27-inch touchscreen on the back as well. So it's called our riser kit. All together, retail price on this thing is $24,000 US. It's going to have this cool wrap on there and be personalized with your name if you win. So all you have to do, like I said, to enter, we're going to be giving away 10 of these in North America, 10 of these, one for each region. As long as you have 22.4 in your tool by the end of the year, you're automatically entered to win. Ends on December 31st. As long as you have it in the tool by the end of business on December 31st, we're going to run a report the next week, see who in each region had it. And then if you are entered to win. And if you win, well, then you win this awesome prize. So I think that's pretty cool. And we're giving away 10 of them. As for next week, we're going to talk about diagnosing intermittent issues. We're going to talk about a lot of engine issues, things like fuel trims and oxygen sensors. How do I diagnose a cat using scan data? There's a little bit of that in there as well. And also they'll talk about maybe intermittent body issues, talk about inputs and outputs and what we have to do there using a scan tool. So we're going to be focused mainly on diagnosing a car using a scan tool, intermittent issues. That'll be next week. So same time, same place, 6 and 9 Eastern. You can go to snapon.com/OT to register on Zoom. The 6 p.m. Eastern, like we're doing right now, goes live to our YouTube channel too. So youtube.com/SnapOn Diagnostics. Make sure if you are watching and you are on YouTube, we definitely appreciate it if you subscribe. It doesn't cost you anything. And then hit the little notification bell as well, so you'll know anytime we go live or post new stuff. If you want to see any of our previous topics that were available in this series, so anything like ADAS, data bus testing, component testing series we did, diesel emissions, thermal imaging, etc., 52 different topics are available, all for free, 24 hours a day on our YouTube channel. If you go to youtube.com/SnapOn Diagnostics, and then there's a playlist for live training. So you can go check that out. And I always say if it's free, it's for me. So I like having free training, access to free videos. It's always good to have. Now it's time for Q&A. If you are watching on Zoom, you came in a little late, just find that Q&A button if you have a question. You can find that Q&A button top or bottom of your screen, type it in, and I'll get to those. Also on YouTube, I see some comments and stuff coming through. So make sure if you have any questions on YouTube, you plug them in there on the live chat. Actually, it's listed as top chat, so I'm going to switch that over to live chat just to be sure. All right, and I want to make sure I talk about my buddy Al as well. So Al also does free diagnostics training 3 nights a week. So on Monday, it's on Apollo, Wednesday's on Zeus, and Thursday's on Triton. So if you're a new user to the tool, or you want to just kind of get up to snuff on the tool, you can do that. First hour on any of the classes, they're going to be on their respective tool, but let's set up your Wi-Fi, make sure that works, because there's a lot of things that are critical to having Wi-Fi in this day and age. Next thing is we're going to set you up with a free SnapOn Cloud account. Make sure that you can share files with your friends and customers and so on. So you can do that. And then walk through code to completion. Here's how Fast Track Intelligent Diagnostics is going to help you diagnose cars easier, faster, and better. That's the first hour. On Wednesday and Thursday, since Zeus and Triton also have scope and meter functions available, he's going to take a 5-minute break, and then he takes another hour just about and goes through the scope and meter functions on the tool as well. A couple real world scenarios, stuff you may be able to use in the shop the very next day. So same time and same place, 5 and 8 Central, 6 and 9 Eastern. If you go to snapon.com/OT, you can register to attend on Zoom as well. All right, looks like we don't have any questions on Zoom. That's okay. We got a couple on YouTube. Mike says, hello, welcome. Thanks for joining us. Quinn says, what's going on, everyone? Happy holidays. Happy holidays to you. If you are in the United States, it is Thanksgiving week, so that's always nice. Nick phoning in or typing in from the UK. Always pleasure to have you drop in. Abel Gracida, hi, happy Thanksgiving to you as well. Nick loves his Zeus. Free training, loves the free training as well. Let's see. So Quinn says, so when I win the Zeus, will it come with 1 or 2 years already equipped? That's a good question. That's a very good question. I'm not sure. I'm guessing you would have to put on a subscription. It may come with a prepaid plan. Actually, nobody told me that. So let me back up here. Yeah, Quinn's looking to win the Zeus. I'm going to look in the fine print here on my slide here. Okay, we can do this too. So I'm gonna. Why can't I highlight this? Here, I'm gonna type in the rules. It may be in there. Might be in there. I'm gonna type it in the chat on YouTube there. snapon.com/diagnostics/Quinn. All right, there we go. You can copy and paste that out there, Quinn, and that will show you the fine print. It may not be in the fine print either, but I will do some research, and if you want to come back next week and ask again, I will see what I can answer for you. Because that's a very good question, because it's not going to work very well without a subscription or a data plan. So we want to make sure that we have that available on there too. And good luck to you there, Quinn, too. I know you're very excited. You know, hope you can win. So hopefully you end up being one of those. That'd be pretty cool, I think. All right, with that, looks like we have cleared the board there of questions. So I'd like to take the time to thank you. Appreciate you taking a little bit of time out of your day, your week, your busy schedule to come and spend a little bit of time with us. Hopefully we got a few more tips and tricks on using more advanced component testing with the tool. And why would I want to compare something over time? Just because when everything's in the same time base, we can see how they sync together, how they react to each other. With that, I'd like to thank you for attending, as I said, already. And if you are in the US, Thanksgiving is on Thursday. So enjoy your Thanksgiving with your family and friends, if that's something you do. And then hopefully we'll see you next week for diagnosing intermittent problems. Enjoy the rest of your night. Enjoy your weekend and take care.